Yeah, let us solve some questions on today's lecture. So, the manager of an automobile dealership is considering a new bonus plan designed to increase sales volume. Currently, the mean sales volume is 14 automobiles per month. The manager wants to conduct a research study to see whether the new bonus plan increases sales volume. To collect data on the plan, a sample of sales personnel will be allowed to sell under the new bonus plan for a month period. Develop the null and alternative hypothesis most appropriate for this situation. So we have to write H naught and H. So it is a research approach. So first of all, we will announce HA and then H naught. So HA is the new bonus plan increases the sales volume, and H naught is there is no difference between the new bonus plan and the old one. In such a case, in such a case, what will be your H naught and HA? So your HA, that the new bonus plan increases sales volume. If it increases sales volume, obviously then the mean sales volume is above 14. So we are talking about averages, so it is mu greater than, yeah, good. And of course H naught is mu less than or equal to 14. Sometimes you can take equal to also. Yes, yeah. We'll go to the next question. Yeah, yeah. So the next question is, consider the following hypothesis test. So we are testing H naught as mu equal to 15 and HA as mu not equal to 15. So a sample of 50 provided means two-tiled. Yeah, yes. Because whenever the alternative hypothesis containing not equal to symbol, it is a two-tailed test. A sample of 50 provided a sample mean of 14.15 and the population standard deviation is 3. So calculate the test statistic. What is the p-value? At 0.05 level of significance, what is your conclusion with p-value? And also use critical value approach to see the conclusion. So one can easily answer this question. So let us try. So one by one, as per our steps, you have to write H naught is mu. Yeah, correct. So mu equal to 50 and HA immediately you have to write mu is not equal to 50. So you should write that it is a two-tailed test. After that you have to fix level of significance. So level of significance is already fixed. It is alpha is 0.05. Yeah. Alpha is 0.05. Now you have to calculate the p-value. For that reason, the other data also you need to write. So in this question, I'm sorry. In this question, they have given mu, sigma. So sigma is known to us and sigma is given as 3. And also we have sample size n is 50. And also we have x bar is also given as 14.15. This is from the data. Now you see that sigma is known and sample size is large. So X bar follows what distribution? So X bar follows normal distribution with mean mu and variance sigma square by n. In such a case, the test statistic Z is X bar minus mu by sigma by root n. But always remember, under H0 only, you have to choose the test statistic. In such a case, you have to write here it is mu naught. Mu naught is what? Mu naught is given in the hypothesis statement, that is 50. So calculate the test statistic as 14.15 minus mu naught is 15 by sigma is 3 by root 50. That is given as minus 2. So now you have to calculate the p-value. This is a two-tail test, not a left or a right tail test. So first of all, how do you calculate the p-value? Because z is negative in our previous slides, we have to calculate the area left side to minus 2 and you have to make it twice. Yes or no? So what will be the p-value? Yeah. So p-value is twice of probability of z less than or equal to minus 2. This is the thing. Now, how do you calculate this number? So, you have to see the normal tables. So, if you see the normal tables, so normal tables, so we need minus 2. So, minus 2 seems to be how much? 0.0.228. So, p-value seems to be p p-value seems to be twice of 0.228. So twice of 0.228 is 0.0456. Correct. Yeah, I'm sorry. It is 0.228. Then you have to compare p-value with alpha. So you know that if p-value is less than or equal to 0.05, you will reject H0. Is it true? Is it true here? Yes. So since this is true, so we reject H0. Yes or no? So this is known as what? A p-value approach. But we have another approach called critical value approach. That also you can do this. So let us go for a critical value approach. So critical value approach, the process is that you have alpha equal to 0.05. Then calculate alpha by 2 is 0.025. Why alpha by 2? Because it is a two-tailed test. Then calculate Z alpha by 2. So Z alpha by 2, we know that for 0.05, Z alpha by 2 is 1.96. Now what is a critical region? That we will write. So you know that So this is the acceptance region. So our test statistic value Z is calculated as how much it is minus 2.00. Is it lying between minus Z alpha by 2 and plus Z alpha by 2? No. Minus 2 is obviously falling in critical region because this number is minus 1.96 and this number is 1.96. This Z is falling here. Yes or no? So what happens? You will reject H naught. Correct? This is what the method of solution for a given two-tailed test based on critical value approach as well as p-value approach. Yes, so we'll go to the next question. Individuals filing federal income tax returns prior to March 31 received an average refund of $1056. Consider the population of last-minute filers who mailed their tax return during the last 5 days of the income tax period. A researcher suggests that a reason individuals wait until the last 5 days is that on average these individuals receive lower refunds than do early filers. Develop appropriate hypotheses such that rejection of H0 will support the researcher's contention. For a sample of 400 individuals who filed a tax return between April 10 and 15, the sample mean refund was $910. Based on prior experience, a population standard deviation of $1,600 may be assumed. What is the p-value? At alpha equal to 0.05, what is your conclusion? And repeat the preceding hypothesis test using the critical value approach. So for this you need to construct H0 and HA. Anyhow, this is based on research. So first of all, we will write alternative hypothesis. So what is the alternative hypothesis? Can you please tell me here? That, so this is the statement. A researcher suggests that a reason individuals wait until the last 5 days is that on average these individuals receive lower refunds than do early filers. So this is what you want to test. This is what you want to research. So lower refunds than early filers. Early filers average refund is 1056. So what is the HA then? So it is average, so mu is less than 1056. And H naught is mu is greater than or equal to 1056. So what type of test it is? It is left-tailed or lower tailed. What they have given in this question? They have given n equal to 400 and x bar is 910. Sigma is 1600. So if you see here, and alpha is 0.05. So sigma is known to us and large sample size. So obviously we use the test statistic as normal distribution statistic because x bar follows normal distribution. So the process is same as in the above. But here we are using left tail test rather a two-tailed test. So the p-value no need to take a twice. We have to take only once. And critical value also no need to take alpha by 2. Just take Z alpha. Any queries? Shall I go further? Yeah. Shall I go further? Yeah. Yes. The Employment and Training Administration reported that the mean and unemployment insurance benefit was $238 per week. A researcher in the state of Virginia anticipated that sample data would show evidence that the mean weekly unemployment insurance benefit in Virginia was below the national average. Develop appropriate hypotheses such that the reduction of H0 will support the researcher's contention. For a sample of 100 individuals, the sample mean weekly unemployment insurance benefit was $231 with a sample standard deviation of $80. What is the p value? At 0.05 level of significance, what is your conclusion? Repeat the preceding hypothesis test using the critical value. So problem is same what we have taken. So I'll write only the statements. Rest of the things you can do. Now tell me, this is again a research hypothesis. So first of all, you should write HA. So which statement you have to take? Yeah, good. A researcher in the state of Virginia anticipated that sample data would show evidence that the mean weekly unemployment insurance benefit in Virginia was below the national average. So national average is 238, so it is mu is less than 238. And HA is there, then H naught is mu greater than or equal to 230. So in HA we have a less than symbol, again it is a lower tailed. Now let us talk about the data. So we have n equal to 100 and also we have x bar is equal to 231 and sigma is unknown and we have S is 80. So we have S is known, that is sigma is unknown. Though the population is not normal, but the sample size is very large and sigma is unknown, we use T tables rather than S, Z. So can we do this problem right? You can do in a similar way. So can I go further? Can I go further? Yes. Yeah. Yeah. We'll go this question. A study by Consumer Reports showed that 64% of supermarket shoppers believe supermarket brands to be as good as national name brands. To investigate whether this result applies to its own product, the manufacturer of a national name brand ketchup asked a sample of shoppers whether they believed that supermarket ketchup was as good as the national brand ketchup. Formulate the hypothesis that could be used to determine whether the percentage of supermarket shoppers who believe that the supermarket ketchup was as good as the national brand ketchup differed from 64%. If a sample of 100 shoppers showed 52 stating that the supermarket brand was as good as the national brand, what is the p-value? And at alpha equal to 0.05, what is your conclusion? Should the national brand ketchup manufacturer be pleased with this conclusion? Explain. So if you see, again it is a research hypothesis. So what will be your yeah, yes, yes. But here I'm not talking about any average. If you glance the question, I'm talking about the proportions. Yes. So that's why here, anyhow, we'll start with HA. Somebody has told me the right one. So P is differing from. So that's why it is 0.64 and H0 is P is equal to 0.64. So obviously this is a two-tailed. What extra we have given? We were given n is 100 Number of people in that is x equal to 52. So obviously P bar is 52 by 100, that is 0.52. Now you have to calculate the test statistic and so on. So let us solve this problem, at least one for proportion. So you have H naught as P naught P is equal to 0.64. HA is P not equal to 0.64. Also, P bar is equal to 0.52. Correct. Sample size N is equal to 100. Correct. Now you have to test whether we are taking a large sample or not. So NP is equal to 64 and N into 1 minus P is 36. Both are greater than or equal to 5. So large sample case. So in large sample case, you know that your test statistic P bar follows normal distribution with mean mu and variance sigma square. So tell me what is mu? Mu is nothing but expectation of P bar, that is P. And what is sigma square? That is variance of P bar, that is P into 1 minus P by N. Correct? Then use the test statistic. So test statistic is Z equal to P bar minus E of P bar by square root over variance of P bar under good. Yeah, you have to check for P, not for P bar. So that is P bar minus expectation of P bar is P, but under H naught, P is taking the value P naught by square root over P naught into 1 minus P naught by N. That is P bar is 0.52 minus 0.67 by square root over 0.67 into 0.33 by 100. So test statistic value is coming out to be, is it 64? Yeah, I'm sorry, this is 64. Then this is 36. Thanks, 64. Sorry. So, sorry. So, this is coming out to be minus 2.50. Now, you just know the value. So, p value can be calculated as, because it is a two-tailed test, twice of probability of z less than or equal to. For negative value, we are taking less than or equal to. If you get a positive value, you will take a greater than or equal to. Minus 2.50. And if you use the normal tables, the answer coming out to be 0.0124. So now you have to compare with alpha. It is obviously less than alpha. So what happened? You will say that reject H naught. So is it clear for you? Yes or no? Any queries? Yeah. Yeah. We'll go to the next question. So we'll take a small break and we'll come back. Let us solve few more questions again. So we solved question number 38, which is a two-tailed test based on proportion. So if you go through question number 44, which is also of same kind, so I'm just skipping it. So we'll go to question number 49. So you see here what extra we have done in today's class. We we tested single population mean, right, with sigma known case, with sigma unknown case. We tested single population proportion with large sample size. After that, we tried to calculate probability of type 2 error, and also we tried to calculate sample size. So these two models let us try for a while. So a consumer research group is interested in testing an automobile manufacturer's claim that a new economy model will travel at least 25 miles per gallon of gasoline. So anyhow, in the question, H naught is given. With a 0.02 level of significance and a sample of 30 cars, what is the rejection rule based on the value of the test to determine whether the manufacturer's claim should be rejected? Assume that sigma is 3 miles per gallon. So anyhow, we are dealing with population mean. Sigma is known to us and sample is also good. So we can use the sampling distribution of x bar as normal distribution because sigma is known to us. Right? Now the question is, what is the probability of committing a type 2 error if the actual mileage is 23 miles per gallon? We will concentrate on B because C and D are same as B. First of all, if you want to calculate type 2 error, I told you that HA should be specified at a particular average. So in question B, HA is specified at a particular average 23. So not a problem. But surprisingly, what is missing in this question? That is X bar. So first of all, you have to calculate X bar and then calculate type 2 error. Like at least a rule, not the exact textbook. Shall we try? So first of all, we'll write H naught and then the remaining things. So the question is like this. So we have H naught is given in the question. It is mu greater equal to 25. And HA, of course, obviously you can write it as mu less than 25. So it is a lower tail. Correct? So obviously you can write that. What else we have given in the question? What else we have given in the question? We have mu naught is 25. Correct? We have sigma is 3 and we have n is 30. Because this is known and this is somewhat large sample, your x bar follows normal distribution with mean mu and variance sigma square by n. So I'm writing directly the test statistic is z equal to x bar minus mu, but under H naught it is mu naught by sigma by root n. This is under H naught. Correct? That is x bar minus 25 by 3 root 30. This is your test statistic. Because we don't know x bar and we have to write the rejection rule in terms of x naught. So we'll go back to the question and see what else we can have so that we can write the rejection rule. With a 0.02 level of significance and a sample of 30 cars, what is the rejection rule based on the value of for the test to determine whether the manufacturer's claim should be rejected? So you have to write the rejection rule for x bar based on 0.02 level of significance. Yes or no? Correct? Now that we will do. So we have level of significance is alpha equal to 0.02. If alpha equal to 0.02, then how do you calculate the corresponding value? So obviously you can write that you have to write the rejection rule for alpha equal to 0.02. So can you please tell me how do you write that? Any hint? Yes, please. Any hint? Any hint? Yes, please. Any hint you are going to give? Yeah, we get the z value at alpha is 0.02. You are right. So z value at alpha is 0.02. Then you have to do the things. Now can you please tell me what is the z value at 0.02? That will do it. So let us take the normal table. So we have the area is 0.02. That is alpha is given. You need to identify z alpha. So can you please tell me where you will get? Yes, please. 0.02. Maybe I think this is somewhat near. 0.02 is coming here. So the corresponding value is minus 2.05. Yes or no? So that's why you will write here the rejection rule is like this. So when alpha equal to 0.02, one can easily calculate Z alpha as minus 2.05. So now you can write the rejection rule based on this. So what do you write? So you will write that reject H naught if Z is less than or equal to minus 2.05 because it is a negative value. So below minus 2.05 is our intention. And also this is a what type of test? Left tail test. Now Z already you calculated. So what is the Z value you calculated? It is x bar minus 25 by 3 root 30. 3 divided by root 30 is less than or equal to minus 2.05. So if you simplify, obviously you will have what is the next condition? You will write here that x bar is less than or equal to 23.88. So this is the rejection rule, and the acceptance rule is greater than 23.88, right? Now what question I am asking you? I am asking you to calculate type 2 error for a particular alternative hypothesis 23. So that we will do. So what is probability of type 2 error? So probability of type 2 error is probability of accept H naught when, which is true, when HA is true. So when we are going to accept H naught X bar is greater than 23.88. That's what we got now. Given HA is true, HA can take any value as per our statement, but you should give a particular value. That's why I'm giving you mu A is 23. Now again, how do you calculate the probability? Convert it into normal. So X bar under HA it is mu A by sigma by root n is greater than 23.88 minus 23 by sigma is, what is the sigma value? What is the sigma value? Sigma is 3 division, yeah, root 30. So this is probability of Z greater than 1.61. And finally, you can calculate the uh, type 2 error. Beta is equal to 0.0537. So this is the value you can do it. So please remember, this problem is an important model. What we have to do, you will be given a rejection rule. Based on the rejection rule, you have to construct the acceptance region and the rejection region. Based on the acceptance region and rejection region, you have to calculate type 2 error. Have you understood? Any queries? Any queries? Yeah, I'll move further. I'll close with a last question. So consider the following hypothesis test. So it is again a left tail test. The sample size is 120 and the population standard deviation is 5. Use alpha equal to 0.05. If the actual population mean is 9, the probability of a type 2 error is 0.2912. Suppose the researcher wants to reduce the probability of a type 2 error to 0.10. When the actual population mean is 9, what sample size is recommended? So I told you, if you want to calculate a sample size, you need alpha and beta, as well as you need Z alpha and Z beta. Yes or no? So Z alpha, how do you calculate? Alpha equal to 0.05. So using that, you can calculate Z alpha. Z beta already, so beta is given as 0.10. If beta is 0.10, you can calculate Z beta. So you have Z alpha, you have Z beta, and also you have sigma, and one can easily calculate the sample size. Do you agree with this or not? Any questions? Yes or no? So you have alpha is 0.05. Then calculate Z alpha. You know very well the answer is 0. And beta is 0.10. Calculate Z beta as 1.28. And also you have sigma. Sigma is 5. And also you have mu naught. Under null hypothesis, mu naught is 10. When we calculate beta under alternative hypothesis, you will be given a particular mu, that is 9. So use the formula n equal to Z alpha plus Z beta whole square into sigma square by mu naught minus mu A whole square. If it is a two-tailed test, you have to write Z alpha by 2 instead of Z alpha. And the answer is coming out to be 214. So this is a problem of identifying sample size. So any queries? So I'll just revise few things. I'll close with this. So please remember, so far we calculated in the last two problems probability of type 2 error and as well as identifying sample size. I want to mention few things here so that you will be comfortable. Like suppose if I gave like this, H naught is mu less than or equal to 10 and mu greater than 10, right? Then you are writing test statistic, for example, sigma known case, you will write test statistic as z equal to x bar minus mu by sigma by root n under h naught. Because under h naught there is a equality symbol, you can replace mu with 10. But while calculating probability of type 2 error, beta is nothing but probability of accept H naught given HA is true. But HA is true for any number greater than 10. So you cannot calculate beta like this. So to calculate beta, they have to mention a particular mu under HA. That mu is called as mu A. That's the reason. Have you understood? Any other queries? Any other queries? So, do you have any other queries? Or we can stop here if you want. Yeah, if you ask me an overview, I'll tell you one thing. In today's class, what we discussed is testing of a single population mean in two cases, sigma known and sigma known, testing a single population proportion when the sample size is large. Both cases we did. Apart from this, the interesting points are the last two problems I'm repeating. How do you calculate the probability of type 2 error beta? It involves two steps. One, using the critical region, you have to write the reduction rule. Based on the reduction rule, you can calculate probability of type 2 error. But mention that for calculating probability of type 2 error under HA, you have to give a mu A, like what we are using in mu naught. And finally, we have calculated sample size. If I give alpha and beta, if I give alpha and beta, you can calculate Z alpha and Z beta. Under H naught, you use mu naught. Under HA, I'll give you mu A. Yes or no? Like in this question, if you see, so calculating type 2 error is 0.10 when the actual population mean is 9. When type 2 error you are calculating, HA is true. So 9 is coming under HA. So this is your mu A. Like that you have to identify. Similarly, in this problem, in B question, actual mileage is 23. Anyhow, 23 is coming under HA, but a particular mu A I have defined here is 23. Understood? Any other queries? Yeah. Maybe we will, the immediate next classes may be on point estimates of population standard deviation, interval estimates of population standard deviation, testing of population standard deviation. Immediately we'll talk on that first, right? Okay. So thanks for today and we'll join again in the next class. Okay. Have a good day.